All right, gang, STAT1150. We're going to get into types of variables and measurements. So far, we've grouped our different types of measurements that we've evaluated, analyzed, considered as either categorical or quantitative. So gender, political affiliation, Likert scale stuff would be examples of categorical variables, and then quantitative, height, weight, and so on. But we're going to actually create some more precise measures of numerical data. So the four scales of measurement that I want you to have on your radar and I want tattooed to your brain are nominal data, ordinal data, interval data, and ratio data. Now, nominal data and ordinal data, I think, are the two easiest to kind of understand. Nominal data is strictly categorical data with no natural ordering. Ordinal data is also categorical, but there is a ranking or a natural ordering. Moving into quote unquote quantitative measurements, interval data is specific to quantitative data where differences between measurements exist, but there's no true zero. Ratio data is the same, but there is a true zero. Now let's dive into each one of these. So nominal scale, what I would want you to know is it's, again, strictly categorical, and there's no, well, that should be no natural ordering, not nor. But anyway, no natural ordering or ranking. So calculating the mean, median, and so on would be completely meaningless. Examples: blood type, zip code, gender, race, eye color. Again, all categorical with no natural ordering. Compare that to ordinal scale. Ordinal scale, again, is strictly categorical, but there is a natural ordering or ranking. But still, calculating the mean, median, those measurements that are specific to quantitative variables would not help us at all. So some examples: socioeconomic status, which is typically defined as low, middle, or high. Clearly, it's a categorical variable, but there is a natural ordering. Same thing with education level. If we were to look at this, examine it from, say, some high school to high school and so on. Income level, depending on how that is measured. If we just take income in terms of the, maybe the family gross income or the adjusted gross income, then it would be quantitative. But if we collect income based on maybe less than 50,000, 50,000 to 100,000, and over 50,000, we would have a categorical variable, and there would be a natural ordering to it. Satisfaction level is another example I just gave too. Interval scale, these are quantitative with an order, and the difference between two values is meaningful, but no true score of 0 exists. So body temperature, SAT score, and credit score would be example of interval scale data, because primarily they're all three quantitative, but a true score of 0 doesn't exist. For example, a body temperature of 0, does that mean that we are in the absence of temperature? No, it's just the way that the measurement scale falls out, right? SAT score, I don't even think you can get a 0 on the SAT. But if you did, does it mean, like absence of score? No, it would just be, again, a statement, kind of a quantitative classification, if you will, of how many questions were correct. And a credit score of 0 doesn't mean that your absence of credit. It just means that there's being extremely low. I don't even know if you can get a credit score of 0. Ratio scale is quantitative with an order, but the true score of 0 exists and is meaningful. So For example, in nursing, you may have a dose amount or reaction time to maybe a medication, pulse, weight, length, survival time. All of these could be zero. A dose amount of zero means we didn't give anything. A reaction time of zero means there was no reaction. Pulse of zero, obviously would not be good. And then weight, there could be no weight, length, survival time. So again, the difference between interval and ratio comes down to does the value of zero exist, and is it meaningful? Now, I want to test your understanding here. Let's think about these. So favorite candy bar, clearly categorical, so it's going to be nominal or ordinal. Weight of luggage, quantitative, so it's going to be ratio or interval. Year of birth, it would be quantitative, but does that quantity really mean anything? An egg size, small, medium, large, clearly categorical, right? So I think the first three are really, really easy. Well, I'm just going to show you the answers. The answers are nominal. Favorite candy bar, clearly just categorical, no natural ordering. Weight of luggage, because a luggage could weigh nothing. We have a ratio. Year of birth would be interval, and egg size would be categorical with a natural ordering, right? All right, test your understanding. Military rank, number of children in a family, jersey numbers for a football team, and shoe size. What are we thinking here? I think the military rank is probably pretty straightforward. Number of children, I think, is very straightforward. Jersey numbers for a football team, does 32 have any quantitative meaning? Yeah, it's just a placeholder, right? Just a category, if you will. And then shoe size, 2, 8, 8.5, 9. Where would that fall? Well, the answer would be ordinal. So clearly, military rank is categorical, but it has a natural ordering. A captain outranks a private, so that gives us the ordering. Number of children in a family, you could have 0. Jersey numbers for a football team, even though they're numbers, it's a nominal scale. So it's just really a categorical placeholder, if you will. And then shoe size would clearly be interval, because a shoe size of 0 doesn't mean you have absence of shoe size. It's just a placeholder for a very, very, very small foot, I believe. That's correct. All right, gang, just wanted to just briefly go over the measurements. One more scale here. We sometimes talk or discuss quantitative numerical variables in terms of discrete and continuous. Now, we're not going to mess with the categorical here. It's still nominal ordinal, as we've discussed previously. But sometimes numerical, we talk about this in terms of discrete and continuous. Discrete just means that we have a whole numerical value and it represents a count. Continuous is the measurement can take on any value within a particular range. So, the number of trips to a dentist is one of the examples I put here. It's discrete. And then, of course, your height would be something that would be continuous. So probably not going to run into these as much as we will nominal, ordinal, interval, and ratio, but it's something that I wanted you to have so you can put on your radar and, of course, place in your notes. All right, that's all I got. Take care.